Okay, in this video we will talk about some basic concepts that are related to calculation in chemistry. So the first thing we will discuss is scientific notation. Now in chemistry we do a lot of measurement, and a measurement is defined as a quantity that has both a number and a unit. Alright, so for example, I have 2 apples. Someone is 17 years old, 32 degrees Celsius, something like that. So you have a number and you have a unit. Now, very often in chemistry and biology, physics, in science general, we meet a lot of small and large numbers. Alright, so for example, if you look at the number in the screen, that is a number, that is the mass of an atom of gold. Okay, so we are not going to use those large number or very small number in our calculation. It's very inconvenient. So a better way to organize our numbers is by using scientific notation. So a scientific notation has 2 parts. The first part is a coefficient, and the second part is the multiplied by 10 raised to a power. So here you have a coefficient is just a number, and multiply, so this is a product, multiplied by 10 raised to a power. So for example, if you look at this number here, 0.00007 meter, and this is equal to 7 times 10 to the negative 5 meter. So what it means is that 7 is a coefficient and 10 raised to the power of negative 5. So in scientific notation, the coefficient is always a number greater than or equal to 1 or less than 10. Okay? And the exponent is an integer. So what it means? So you look at the number 11 here, you see 11 is what? 11 is greater than 10. So our coefficient has to be smaller than 10 and greater than 1. So the way for you to actually write that down is by doing a so by having a coefficient, the 2 parts, the coefficient here, and then the exponent, the times the exponent here as an integer. Now the second thing here is that we have 134. So this one we have to convert that into a okay, let me see. I need to I need to test this a little bit. I need a pen. Okay, here we go. Alright. So what happened is that 134 is the number, actually is greater than 10. So what happened is that we want to make it into the product of a coefficient and 10 raised to a power. So we have 1.34 is a number the greater than 1 and smaller than 10 times 10 to the second. Now, how are we going to get the exponents here? When writing numbers are greater than 10 in scientific notation, the exponent, you see the exponent here, is positive, okay? And equals the number of places that the original decimal point has been moved to the left. So for example, let's look at this very big number here, 6,300,000. And if you look at so this is a 6 million, right? So the million. And now if you look at the dot here and then you move, so let's say so let's say that you have the coefficient is 6.3. Okay, so the coefficient is 6.3, and then you stop at 3. So let's start with from the far right and move, let's say 1, 2, 3, 4, 5, 6. Okay, so you move 6 times. okay, to the left. So you have 6.3 times 10 to the 6 here. Okay, the same thing with this number 84,450. So what it means is that this is 1,000, and what happened is that you want to have your coefficient is something greater than 1 but smaller than 10. So what it means is that you would have 8.4. Okay, so you would stop over here. Now if you stop over here, so let's start from the far right. You have 1, 2, 3, and 4. Okay, so now you have times 10 to the 4th power here, and then you just have to rewrite the number here, 8.445. Now what happens if the numbers is smaller than 1? Okay, so the exponent has to be negative and equals to the number of places that move to the right. So for example here, the 8, of course, this is 0.00008, so this is smaller than 1. Now what happened is that you want to have your coefficient greater than 1 and smaller than 10, so it's 8. Okay, but from this decimal place, move to 8. So how many places that has been moved? So again, 1, 2, 3, 4, 5, 6. Okay, so 6 times. So this is 8 times 10 to negative 6. The same thing with here. So we would have our coefficient is 7.35, right? Because this is the coefficient, it has to be greater than 1, smaller than 10, and so we will stop at here. Okay, so from here to here, how many places? So let's count. 1, 2, 3. So 3. Okay, so your answer would be 7.35 times 10 to negative 3. Now let's try to write the following numbers in scientific notation, and with these number, they would say that this is in standard form. Okay, so these numbers are in standard form. Now let's pause the video and try on your own. Okay, so here's the answer. Now let's review. So 60 is greater than 10, right? So you want to have a number coefficient that is less than 10 and greater than 1. So this is 6. Now what happens if you have 6 here? So we would have from the right and move 1 over to the left. So that would be 6 times 10 to the 1 power. Now the same thing with this number. So this number is actually less than 1. So the exponent has to be negative. Okay, and at the same time you want to have over here, so you start with a 9. Okay, so you have 9, and then let's count. Okay, so let's say 1, 2, 3. Okay, so that would be 9 times 10 to negative 3. So 6.7, it looks like perfect, okay, but this is not in scientific notation. Why? Because the scientific notation, it has 2 parts. Remember, the first part is a coefficient, and the second part is the multiply of 10 raised to the power. So 6.7 is not a scientific notation yet, because it's missing the multiply of 10. So here's the correct one, 6.7 times 10 to the 0. Remember that we have a raised to the power of 0 would be equal to 1. This is from algebra 1. Now the same thing with 71 times 10 to the 3rd power. This looks like a scientific notation, but this is not. Not yet. Because of what? Because if you look at the coefficient here, the coefficient is greater than 10. So what happened is that you guys are going to make this happen. So this is quite a little bit tricky. Now, so let's say 71, and how can you how can you move from 71 to 7.1? So 71 from 71 to 7.1 is that you divide by 10, right? Yeah, okay, you divide by 10. Now what happens if you divide by 10 in this case? Remember, this is the equal sign. So what it means is that when you, let's say let's say that I have 71 times 10 to the third power. Okay, so what it means is that I want to have I want my final answer to be 7.1, because 71 is greater than 10, so a number that lower than 10 would be 7.1. So what does it mean? It means that you need to divide this number 71 by 10. Alright? And remember that you also have the equal sign here. If you divide this by 10, you have to what? You have to multiply this number here by 10 as well, so that it makes the two sides equal. Now what happens is that you have in this part here, this coefficient here is 7.1. Now how about our exponents? So here with the base 10, we have 10 raised to the power of 4. Okay, so this is a little bit of a review of algebra here. So assume that we have same base. So let's say that I have same base a. Now if I have a raised to the power of m multiply by a raised to the power of n. So this would equal to what? This would equal to a raised to the power of m plus n. Okay, so in this case this is correct, because we have 10 is a 10 power of 1. So you would have 10 raised to the power of 3 plus 1 equal to 4. Now what happens if I have same base again, a is my base, raised to the power of m, and divided by a raised to the power of n. So in this case I would have the same base a, right? But here the power would be m minus n. Okay, all right. So now with this question, you have for this number definitely greater than 10. So what happened is that you want to have your coefficient here, okay, at this point. So 4.89 would be smaller than 10. So what happened is you start from the far right and you move 1, 2, 3, 4. Okay, so your answer would be 4.89 times 10 to the fourth power. And this is the same thing. So in this case, the number is smaller than 1, so the coefficient has to be negative. The exponent has to be negative. And you start with 9. Right? Excuse me. So you have 9 here as a coefficient. And then you would start from this point here, this decimal place here, and then you move 1, 2, 3, 4, 5, 6, 7. Okay, so you have 9 times 10 to the negative 7. Now, we will continue our discussion with the next video.